let me just repeat that. The first step is to put it in standard form. In this form, 0 on the other side. Then you see if there's a GCF. There isn't always one, but you should always check for it. And then the third step is factor it. So that's when you think about all the different types we did last week, and you say, okay, which one is this? What are my steps? Okay, so we're going to practice that. The actual end of it, where it's like solving, is super, super easy. Really, the most work, again, is just factoring. So the first thing I want you guys to notice is that this is not in standard form. We want a 0 over here. So I'm going to move the 5x squared to the other side, okay, which will give me a 0 there, which is what I want. And I have negative 5x squared minus 20x. I can't put them together, like subtract them. They're not like terms. But I will put the biggest exponent first. That's important. That's standard form, okay? Everybody on one side together. Exponents are in descending order, okay? And then step 2 is to factor out a GCF. Do we have a GCF in this problem? Yeah. What is it? Yep. Both of these are negative, so that's common, right? We're going to take out a negative. They both have a 5. 5 goes into 5, of course. 5 goes into 20. And Chick-fil-A, $2, $1, we'll take 1. So the GCF is negative 5x. Whatever's left over goes in the parentheses. So when I divide this guy by negative 5x, I get x. When I divide this guy by negative 5x, I get, be careful here, positive 4, right? Because it's a negative divided by a negative. You can check it real quick, guys, without showing any work, just in your head. Negative 5x times x, yep, that's negative 5x squared. And negative 5x times positive 4 is negative 20x. So last week, this would have been done. There was no equal sign in it, equal 0 or anything. It was just that. We would have said, okay, that's factored. There's nothing else we can do to it. This is the new part right here, the solving. You set each of your factors equal to 0. So I'm going to set negative 5x equal to 0, and I'm going to set x plus 4 equal to 0. Just both of them. I set them equal to that 0 separately. And then I solve. They're just little 1-2-step equations. Divide by negative 5, x equals 0. X is negative 4. Those are the two solutions. Because if you're a quadratic, which this is, that of exponent 2, you're going to have two solutions. And there they are, 0 and negative 4. So if I plug a 0 into the original equation, it would make both sides the same. If I plugged a negative 4 into the original equation, the left side would equal the right side. Okay, so that's the only extra step. Let's do another one. Not in standard form, right? Because there's not a 0 on one side. So we have to bring the 49 over. We want to bring 49 to the other side. So I would subtract it. That leaves me with 16x squared minus 49 equals 0. Do I have a GCF? You can look at 16 and 49 and try and divide it by 2, 3, 4. If they don't have a common factor. So there is no step 2 to do. Okay, now we're at the factoring step. Remember, it didn't have a GCF. Okay, so is it our chart problem or is it the difference of two squares? Difference of 1, 2 perfect squares. Yeah, we love these. These are the easiest ones. We go right to our parentheses. Remember, one's a positive, one's a negative. So difference of two squares. I make 2 parentheses, 2 different signs. And then you just do the square root of the first guy. That would be 4x, right? The square root of 16 and the square root of x squared. That goes in the first spot. And then the square root of 49 goes in. So the parentheses are always identical, but one's a plus, one's a minus. That's the only difference. Now, if we were just factoring, that would be the answer, factored. but we're factoring in order to solve. So we take each of our factors and set them equal to 0 and solve them. So aren't you just going to get the same answer, but one's positive and one's negative? So subtract 7, divide by 4. And you can leave it as a fraction. You could change it to a decimal if you wanted to. And we'll get the same exact thing here, except it'll be positive. Either answer would be fine. You don't have to show both. Okay? So there was an example of a GCF factoring. There's an example of difference of two squares factoring. Let's do one more, the hardest one, which is the long chart ones. Okay? So one more example, then I'm going to start the homework with you and do quite a few with you. But guys, listen, this is not one of those assignments that you can just float through. We have to know how to factor, like bosses, for real. Okay? We have to. Last one in the notes. So if, especially on this one, these are the hardest ones for most students. If you don't know how to do this, go back and watch the video. Okay, so first thing is it's in standard form. Is this already in standard form? Yeah, we have a 0 over here, and our exponents are in descending order. X to the second, x to the first, constant. And then we say, okay, is there a GCF? 3, 5, nope, there's no GCF. Then you say, okay, which one of those factoring types that she showed us is this? And because it's a quadratic trinomial, it's a chart problem, right? We make our little chart. And remember, we're finding which numbers multiply to get something and add to get another something. And what are those something? A times C and B. And that's just something we have to know. So A and C, 3 times negative 2 is negative 6. And our B value is 5. Keep the signs. 3 times negative 2 is negative 6. And the B value is 5. Okay? So think of the numbers that we know that multiply to get 6. 1 and 6, 2 and 3. Now, in both cases, I could make a 5, right? If I subtract those, I could get 5. If I add those, I can get 5. So it's got to be one or the other. It can't be both. Like, let's start with the 1 and the 6. Obviously, 1 plus 6 is not 5. But if I make the which one negative, I can get a positive 5. Which one? The 1. So it works there. Does it work over here? Negative 1 times 6, is that negative 6? Yeah. Why won't 2 and 3 work? Well, if I use 2 plus 3, yep, that's 5. But is 2 times 3 6? No. We would need one of these to be negative 6. So that's why it doesn't work in both columns. It has to work in both. Now reminder, if that 3 weren't there, look. Don't do extra work. If the 3 isn't there, you would just go right to this answer, x minus 1, x plus 6. But the 3 is there, okay? When that happens, you can't use the shortcut. You have to do the bringing down of the outside two terms and split the middle. So let's review this. 3x squared, there's my first term. Bring down the minus 2 is my last term. And when we split the middle, we're splitting it into two numbers. That should equal 5x. Whatever I write here should equal 5x. It's these two numbers with an x put on them. So it's negative 1x plus 6x. Now listen, the order of these two numbers doesn't matter, but if you put the negative first, it is easier, okay? But it's not wrong to put the 6 first. You just have to factor a negative out of the second set of parentheses, and that just gets a little confusing. Now we have 4 terms, right? 1, 2, 3, 4. Brought down the outside 2. These 2 right here equal the 1 above it, okay? This is where we split it into 2 sets of parentheses. And now this problem is just like the first one we did, just finding the GCF. The GCF of these 2 is just 1 or 1x. right? They both have an x in common. So we don't have to put the 1. If you do, it's fine, but you don't need to put it. So I'm just dividing both of these by x. Okay. And in the back, what do I have in common? Just 2, right? And if we did it right, and we did, our parentheses should be identical twins, exactly the same, no signs different or anything. That should happen every single time you do these problems, okay? And we're ready to write our factored answer. Remember, whatever's in parentheses, those twins, you can put it here or here. It doesn't matter. Either set of parentheses, you can put that 3x minus 1. And remember the GCS, where I put hearts around them, x plus 2. So if we were factoring, that would be the factored answer. But we have to go one more step, which is solving. So you have to set these equal to 0 and solve. And guys, I don't care really how much work you show here. Like, I hope you don't have to show any work here. I hope you all know that that just equals -2, right? You don't have to show that work. Same thing here. Add 1 to the other side. I don't have to see it. I know what you're doing when you write that. You could even go to the next step if you needed to without showing the work. I want you to be able to do some of this in your head. So those are my 2 solutions. I should always get 2 solutions. Okay? These are the worst ones right here. If you understand this, but you're just annoyed by it, you're in good shape. But if you know how to do it, no one likes it, okay? But if you know how to do it, that's good, because they're not going away. All year, they're not going away. So you have to learn how to do those, all right? So that's it for the notes. We are going to the workbook page, and I'm going to do some with you, okay? I gave you 2 of these, just 2. The rest are the other easier ones. Okay. So, you already ripped out page 161. I already told you the assignment, but you're going to need another piece of paper. Okay, so as long as you can just look on somebody's, there's no room on that, I don't think, unless you write super small. So you're going to kind of run through the steps in your brain. Is it in standard form? Yes. Does it have a GCF? Yes. Right? 6 and 2 have a what in common? 2. There's 2 x's and 1 x? 1 x. That's the GCF. So we're just dividing these 2 terms by 2x. Whatever's left over goes in the parentheses. Just the reverse of the distributive property. So 6 divided by 2 is 3. Subtract the powers. 2 minus 1 is 1. Minus 2x divided by 2x is 1. There it is. That's factored. There's nothing else I can do with that. Then I set each of my factors equal to 0. 2x is a factor. 3x minus 1 is a factor. And I solve them. So 0 is one of my solutions. Add 1. Divide by 3. So 0 and 1/3. Those are my 2 solutions. Question on number 1? Brian. Come on, you can't sleep through this. I'm doing homework problems with you. Are you sleeping in algebra 2? Come on. All right. Any questions on 1? It takes practice. We've got to practice these. Okay, number 2 is not in standard form. We need to have a 0 on one side. So just when you look at it, you can tell immediately I need to move this 7x to the other side. So I got it in standard form. Does this one have a GCF? Yeah. They have an X in common. Remember, a GCF can be a number, a letter, or both. Right? We had a number and a letter in the last one. In this one, just a letter. They have one X in common. That's factored. Don't forget to solve it. We set each of our factors equal to 0. X is a factor. X minus 7 is a factor. So look, we don't even have to do any work for that one. X equals 0. That's one of your solutions. And X equals, well, add 7 to the other side. Don't forget, you need to do the other side. So 0 and 7. How are we feeling? Are we getting these? Is number 3 in standard form? No. Biggest exponent goes first. 0 on the other side. Do we have a GCF in this one? 5x. Yeah, 5 and x. 5 goes into both of those, and they have an x in common. So that's my GCF. $20 divided by 5 is 4. X to the second over x to the first is just x, right? If I multiply these two together, I would get 20x squared. 25 divided by 5 is 5, and those x's cancel. So there's the factored answer. Set each of your factors equal to 0. So 5x is a factor. 4x plus 5 is a factor. And solve. So looking ahead, you're going to have problems where it says to factor. So you stop at the parentheses. This would have been your answer right here. The directions were just a factor. If they say to solve, you have to go this one step further and set your factors equal to 0. Okay, I'm going to do number 4, but not talk while I do it. So you guys do the same thing. Like, try it and look up periodically and check your steps with mine. Because this one's already in standard form, and it has no GCF. So then you have to decide what type is it. Quadratic, trinomial, it's a chart problem. Okay? See if you can come up with a chart by yourself, and then copy mine if you made a mistake. That's a positive 5, sorry. Got to do the shortcut on this one. right? Because there was a 1 in front. Once you have your numbers, you don't have to do the bring down the outside to split the middle. We love it when we get a chart problem with a 1 in front. It makes it so much easier. Robbie, I think you were first, and then you can go. Yeah. So, guys, don't just copy my work, though. Try it. And I'm going to come around and help.